Okay, in this video we're going to do some work with Ohm's Law, and we're also going to do some power stuff. I do not believe that you are able to take any kind of scratch paper or whatever in with you when you take the test. So you're going to need to be able to work some of this stuff out, and they expect you to do that from memory unless they have some aids available, because these are not open book tests. I put up these two little wheels for calculating. You cover up the one that you want, like if you want to know what E is I times R. If they're next to each other, they multiply. If one is over the other, they divide. Okay. But you got to remember which goes where. And I don't know. Every reference book I've ever picked up that does this circle stuff has PEI. And I don't know what their problem is with putting it as PIE, because pi is pretty easy to remember. And the order in multiplying or adding doesn't matter. Okay, plus I is in this quadrant over here anyway. These are great. If you can remember what goes in them, I'm not going to speak against them. I don't use them because I have a tendency not to remember who's on top and what's on bottom or whatever. I remember the fundamental equation. E, which is the same as V, by the way. You're going to find that the books, study guides, are still kind of in transition. Some are using E, some are using V. E was used for a long, long time because V stood for valve, which was the British term for a radio tube. So they had to use electromotive force. And I for current rather than C, because C was being used for capacitors. I is the first letter for the French word for current. And I don't know what that is. Somebody said intensity, but no, it doesn't stand for intensity. It's the French word for current. Anyway, I remember E equals I times R. And they're in alphabetical order. So if you can remember E, I, R and write it down in alphabetical order and put E on the side by itself, you're okay. And this is just simply pi. P is equal to I times E. Now, why do I need both? Well, obviously we need to do some power calculations. We're going to be doing voltage and resistance and current, whatever. But notice that both of these have an E and an I in them. So depending on what information they give you, you can kind of jockey these around algebraically and calculate power and current and resistance or whatever for just about any combination. The first thing you want to do, though, I just remember these two fundamental equations. And then I write the two others that are missing. Current is going to be equal to voltage divided by R. How did I get there? I divide both sides by R. And those cancel. So I then is equal to E over R. And do the same thing here. And R then is equal to E over I. Do the same thing for these. This is already written out. For that, let's divide both sides. Let's get one for E. E is equal to the power divided by the current. And the current is equal to the power divided by the voltage. Notice that in this one up here, and I'm going to erase my canceling out here, so we got a clean thing. So I times R. What if I want well, this is even a better example. We're going to work some examples, so don't sweat it. because this relationship of power over the current, that gives me voltage. So if I'm over here and the stuff I've been given is power and voltage, and I don't know what the current is, I can use this as a substitute. You'll see how that works. So make sure you know how to get all three equations for each one of these. Okay? That's the important part. I just start with a fundamental equation and then solve for each letter until I have all three letters solved for. And you can do that on your scratch paper that you're given when you sit down and do your test. Do that first. That'll get your brain into math mode. It'll get you into test mode and help you filter out any distractions that are going on in the testing center, and you'll be ready to go. Okay. Let's look at a case. Let's say that I'm asked to find out, I want to find out how many watts of electrical power are used if 400 volts is supplied to an 800 ohm resistor. Okay, so this is my E value. This is an R value. And they want to know watts. I don't have any R over here. I don't have any current. But I do have a value for resistors over here. So let's see. R is equal to E over I, but I don't know the current. They want power, so that's not going to work. I need... here we go. Current is the voltage over the resistance. I have a voltage, I have a resistance. This will get me I. I need to know power. So this is the equation I'm going to use. But I don't know the current. Well, the current, I can substitute E over R for current, because this says, remember what equations are. This says this side is identical to this side, just in a different form. Okay, so power is what I want. It's equal to the current, which I don't have. So I'm going to substitute E divided by R times the E. So this is just the I part of this up here. But I can simplify this. So power then is equal to E times E, which is E squared, over the resistance. This will give me the watts. And I have those two values, so let's plug those in, and I get 400 volts squared over my resistance of 800 ohms. Now, don't jump the gun and start getting rid of zeros here. You got to do exponentiation before you do anything, so don't do that. Just get your they'll give you a scientific calculator, or you'll be allowed to bring one in. Okay, so let's just enter that in. We got 400 squared, and this is divided by 800 equal, and this says I get 20 watts of power. Oh, it's not right. I got an extra zero up there. Yeah. Oftentimes, all these newer scientific calculators have a fraction template key, so that's a good place to do it. 400 I love it when I make mistakes. Okay, squared over 800 equal, there we go, 200 watts. Makes more sense. Okay. The key takeaway here, though, is I was able to use one of the Ohm's Law formulas as a substitute for one of the letters over here. There's no R here. I have a voltage and a resistance. So this gives me a voltage and a resistance, and that's equal to I. And I have an I here. I don't know what the current is, so I can substitute that in. That's all I did. This is an I that's been substituted in here. Then do the simple algebra. E times E is just E squared. That's all over R. Okay. Now that you got the basics, we'll do more examples in the next video.